Okay, this is Old Man Coding, and I am a programmer who has been a professional since 1991. So, definitely old man, approaching 50 years old. And this web series is about an old man doing stuff that might, on the surface, be unintentionally bad, unintentionally clueless, definitely all about learning new things. So I'm not proposing that this is a tutorial series. I'm not proposing that this should at all be used to educate yourself about these topics. This is simply an old man fussing around, trying real hard not to be crap. And my particular focus lately has been on Rust. And because I really want to learn this language, because I think that its memory safety is an ultimate good. And I come from, well, let's start with my CV, shall we? In 1991, I was doing Pascal programming. I was doing assembly language programming. I was doing a little bit of C programming. Later on, I moved to exclusively C, then C++. Also a smattering of Fortran. And because I was forced to take a class in it, a little bit of COBOL. Tried Java, bounced off of it pretty hard because I hate inelegant language design. And Java is one of the most inelegant designs for language possible. I was coding on a job, and I decided to create my own interpreter language for a utility that we were actually selling to corporate customers for like $15,000 a pop. And my interpreted language that I created, while being a toy language, was also really crappy. And a job that should have been pretty instantaneously processed, at one point took 5 hours to process because I had no clue actually how to write an interpreted language, and memory allocation and reallocation and reallocation and reallocation made it slower than anything you could possibly imagine. But we had already sold this solution to a customer for an amazing amount of money. And the professional services guy was on site, and he was saying, hey, we're trying to do this job, and it's taking, an awfully long time to do. And it's also pegging their processor pretty hard, and they need that processor to do other corporate things. So, help. And I realized at that moment that that people were paying an awful lot of money and expecting a level of service that I wasn't giving them. So, on the day the professional services guy called, I said, that's interesting. Let me look at that and get back to you. Which, by the way, if you haven't learned, you're in any kind of tech support or professional services, whenever you don't immediately know the answer, that's what you say. I don't care what the question is. That is what you say for an answer. That gets you off the phone, and it gets you to a point where you can research it without embarrassing yourself in front of the customer. Well, what I did was I completely scrapped my toy interpreted language and cast about for a new language to write the solution in, just to get the customer going. And my first instinct was Java, because in 1995 Java was all the rage, and so I started coding the solution that I needed to give to the customer just to get them going. And I found Java to be a hellscape of boilerplate code and pure object-oriented design, which, again, was all the rage. Now, I was well aware of object-oriented design in 95 because I had done some C++ work, and I couldn't understand why Java decided to be so massively overcomplicated to get a program going when C++ is it's function main. That's it. And so I bounced off of Java, thought it was a horrible language. But at the time, I was sort of at a loss for what I should choose instead. I didn't want to go C, C++ because I knew the languages. I've coded solutions in the languages, but the languages weren't easy enough to get a customer solution literally inside an afternoon. And while doing primitive web searches on what language I should choose instead, I ran across Eric Raymond's article on why he really liked Python. And at the end of reading his article, I downloaded Python, the 1995 version, which I believe was 1.5. And he was right. It was easy to learn, easy to get into, and not only did I code a working solution for the customer who paid $15,000 for our services, but also coded it very well. It was full featured, what I gave them. It was not only a replacement for the toy interpreter and the configuration that I had there, it was better than what they had bought. So morally and ethically, I thought my butt was covered. Hey, I gave them more than they bought. And it took me roughly 2 hours to grasp all of the underlying concepts of the Python language. And then it took me a couple more hours to code my solution. And it just worked. First time, it just worked. And I was shocked, for going from basically zero knowledge of Python to coding a good solution that worked with remarkably little debugging work. Impressed the heck out of me. So, thus started my love affair with the Python language, which lasted 20 years. And in those 20 years, while I experimented with other languages, I was sent running back to Python. And they say, well, Python's slow. It's mainly single-threaded, especially back in the day. The global interpreter lock was a real problem with getting any kind of real performance out of Python. And my thing was, and quite frankly still is, that developer time is always more expensive than CPU time. Always. And even more importantly, the language you choose also determines how difficult your life is going to be debugging something. And with Python, I rarely ever had to do anything more than a smattering of debugging, and mostly that was like me fat fingering a key or some basic kind of error that you could fix in 5 seconds once you knew what the error was. And I was able to program applications, some massively complex programs, and possibly 1/10 or 1/100th of the time it would take me to do it in some sort of compiled language, or 1/1000th the time it would take me to do it in Java. And the whole world for a while went Java crazy, and it really was problematic for my career for a while, because you don't know Java? Well, it's not like I don't know Java. It's just I'd rather tear out my own eyeballs and stuff them up my anus than to learn how to do real applications in Java. And I truly, honestly believe that the developers of Java should not breed. But more importantly, the IT directors that just kind of piled on en masse onto Java should all not breed, because they're lowering the IQ of the human race. And so it's very hard to find somebody who wasn't like dazzled by Java. And I spent some years in the wilderness there. And then, of course, people suddenly figured out that Java is a crap language, and then they discovered that Python is a really good language. So I was vindicated, unfortunately. I was vindicated about 10 years too late. And went through a lot of years where I didn't have enough work for my skill set, because I absolutely refused to code in Java. Now, at this point, let me be clear, I'm basically an incredibly opinionated coder. If you don't like this, stop the video now. I don't care about monetization. I'm not going to ask you for likes or subscriptions. I really don't care. This video series is not about earning me money. Whatever. Like it, subscribe, whatever. Do what you want. And I won't ever set up a Patreon page, because this web series isn't about making money. So that means I get to say what I want, and that means I get to piss people off. And I pretty much figure right at this point I've pissed off every single person who has liked Java. And I'm sorry, but your taste as a coder is crap. It's crap. If you've ever liked Java, if you didn't just take a look at it and go, oh my God, what a hideous, disgusting mass of bad decisions, then you're a bad coder. Because coder has to have taste. And a coder has to be able to look at an extremely technical problem, and yes, choosing a language is a technical problem, and be able to sort of at least have a starting point towards a path to a solution. And I don't think anybody who likes Java has taste, and I would never hire them at all. And In fact, I would be asking them, why are you a coder if you like this language? That's how opinionated these videos are going to be, by the way. I'm not going to hold anything back. So, brings us to about 2015. Still Python. Finally getting more work to fill up my day and to fill up my bank account. And I take a complete, absolutely shattering 90-degree right turn into web development. Specifically the LAMP stack, PHP, MySQL, for a consultant job that I was doing. The consultant job that was supposed to last 4 to 8 weeks and ended up lasting a year and a half. And one of the requirements was that it be in PHP. Well, I had dabbled in PHP before. I had a site that had a customer management software written in PHP that was badly written, horribly designed, barely functional. And I sort of had to completely maintain it while also rewriting it from the ground up in Python. And so I had to learn PHP pretty much from, a complete ignorance of PHP to working at it in a professional capacity to service my customer. I had an ethical or moral obligation that if I'm taking money from them, then I'm going to give them good service. But it also required me to learn Python in an afternoon. PHP in an afternoon. And be productive in PHP inside of an afternoon. And in 4 hours, basically, I went from knowing nothing about the language, other than, hey, web developers use it, to being pretty effective in programming in it. And so my day-to-day coding basically bifurcated to 50% maintaining old code in PHP and migrating to a new code base in Python 3. And so for a couple of years, I was bouncing between the two, and quite frankly, I couldn't tell the difference between the two. Ultimately, I could not tell the difference between the two. Their library ecosystem was pretty much identical. Their batteries included libraries was basically the same in terms of the functionality it allowed you to have from the ground up to start with. I found that PHP's package management system was not as good as Python's, but doable. And so, yeah, I was satisfied. Hey, listen, I'll do PHP if I have to. And I don't really mind it. But I'll do Python for my passion projects, for projects that I'm allowed to use Python. And I was satisfied for a great deal of time. But in the background on the web, on the net, there was a hint of a whisper that there's this new thing going around. All the cool kids are using it. And, if you want to be part of the cool crowd, you got to check this out, man, because it's awesome. And that was Node.js. You know, I looked at it and I said, yeah, okay. You know, it's a JavaScript command line interpreter. And I took a look at its ecosystem. I took a look at NPM. And I said, yeah, okay, it's obviously an up-and-coming language. And, people are using it for real projects and stuff like that. But you know what? Anything Node could do, Python and PHP could. And so I didn't really see the need to expand my skill set into Node.js until ES6 came out, ECMAScript 6, which, in my opinion, turned JavaScript into a real programming language. And usable for writing non-toy applications. And, previously I had the impression that JavaScript was basically a toy language that's used to make your web pages look pretty and, I don't know, move text around on the screen and, set some CSS properties dynamically and so on and so forth. I never really looked at it, gave it a chance to look at it as a programming language that you could code solutions in. And when ES6 came out, I started to take a look at it and started to get excited. Hey, this is actually a real thing now. And so about a year and a half ago, I got another consulting gig. At this point, I'm 100% a consultant. And I work from home. And in fact, in these videos, you'll find that I live in a working household with 2 kids, a husband and wife, and yet another housemate. And so, and this house isn't that big. So there might be bangs, there might be shouts, there might be inappropriately loud laughter, and for the 5-year-old there might be some yells of indignation. But for the past 5 years, I've been 100% a pure consultant. It allows me to take vacations when I want them, to work from home, to not answer really to a boss. I mean, the customer is the boss, but not answer to a boss who thinks he knows what he's doing, but really doesn't. And telling me to go down technical directions that are not the best technical directions. And I've been lucky, actually, in the past 5 years, to work for project managers who would trust that I knew what I was doing and would just give me the outlines. We needed to do X, and I would say, okay, I'll do X, and I'll go off and do X, and they wouldn't really care how I did X, which makes my day-to-day life much easier and my job satisfaction much easier. And so, as a consultant, I wouldn't say I have a consultant business. I am a consultant, and I am my own business. I have exactly 1 employee in my business, and that's me. But, when a new consultant gig comes up, I get to be my own project manager. And for this project, shortly after ES6 was kind of really pushed out into the public, I decided that I was going to write this new application I was called upon. Just a basic website with some data processing. And do it in Node, and that would be a great learning opportunity. Now, I'd been doing JavaScript all along for web development stuff, so I knew the language. So I figured it would be a very quick process to learn everything I needed to know, which actually didn't turn out to be the case. Nothing in Python and nothing in PHP prepared me for the asynchronous nature of node development and promises and all of that. Now, Python has since sort of stolen that from JavaScript, but for the 20 some odd years that I was using Python for projects, and for the 10 years I was using PHP for projects, I was never confronted at all with the concept of asynchronous programming. And so that was I was coding along. Yes, just like Python and PHP. I learned the basics of the language in less than 2 hours because I had used it before on websites. And in an afternoon, I'm being productive, and then I hit the wall of asynchronous programming and stumbled over it. And suddenly, it really took me like a week to fully grok async await and the various promises functionality, and but once I got firmly in my mind what those concepts were, I was slinging them about all over the place. I had no problems out passing messages and doing all sorts of interesting things, pseudo multi-threading, and for the past 18 months I have basically been solely focused on working in Node for this project. And I pretty much, within the first month of coding Node, I feel that I became an expert at it. And it's not that hard to become an expert at Node, especially if you spent years and years and years coding JavaScript in the first place. Then it's all about just learning the Node libraries and learning the NPM ecosystem and stuff like that. And now, I guess I should explain that, to me, an expert, when you say expert at any field, it's kind of, I don't know if it's apocryphal or not, but what Einstein said: being a genius is not knowing the answers, it's knowing where to find the answers. And I think also a little bit of being a genius is knowing which questions you should ask. You should ask to get to the answers you need. And sometimes framing the questions as, is the genius part of being a genius and being the expert part of being an expert. I always love those those articles about what do you expect when you go in for an interview? Well, expect FizzBuzz. Expect to be asked how to code FizzBuzz. Well, to me, anybody in an interview situation that says, well, how do you code FizzBuzz? I don't say I would be rude enough to get up and walk out of the interview upon being asked that question, but I would say I'd take the interview a lot less seriously, because coding is not about learning by rote. You don't want to go into an interview knowing your solution to FizzBuzz. What you want to know is that if a client, a customer, or your boss comes to you and says, you know, old man, I need you to code FizzBuzz this afternoon because the client's demanding it, that I know that I could go online, type in FizzBuzz into Google, and see a bunch of solutions that other people did, and then choose between them the most elegant solution. And the idea that people would ask in interviews technical questions, well, code me up this, is the most profoundly wrong-headed ways of figuring out who's a good coder and who isn't. The best way to do it is simply asking them about a problem and then ask them to do a stream of consciousness about how they go about solving the problem. Not give them the solution to the problem, but simply how they would go about trying to solve it. But that would require an interviewer who actually knows what the heck he's talking about. And what I've found is that most interviewers are actually from human resources or who are in management, managers who manage coders, but who couldn't code themselves out of a wet paper bag. The few times that I've actually been interviewed by a coder have been some of the most rewarding interviews. Because guess what? We sit down and we have a conversation. We don't have a bunch of pre-written questions about stupid solutions that you're supposed to give them whole cloth. And when I've actually sat down in interviews and talked to real working day coders, then it becomes an hour-long conversation about, what their job is, what problems they normally run into. And then by having that conversation, they see that you're saying, oh, you have these problems? Well, maybe this is how I'd solve them. And you get a dialogue going on. But most businesses that hire coders are idiots about hiring coders. Which is why I think, what was the statistic? Like 90% of software projects fail? That's because you have managers who don't know how to code interviewing coders, and so they hire bad coders. So anyway, that's my rant about that. Anyways, so back to Node.js. I like Node.js. Honestly, anything that I could code in Node.js, I could also code in PHP and Python. There's very little daylight between them in terms of what they can do. But one thing that made me say, okay, Python is in the past, PHP is in the past, is the fact that Node uses Google's V8 engine. And every 6 weeks or so, Google releases a new version of their V8 engine. And every time they do, something gets either faster or more memory efficient. One or the other of them. Or both, actually. And Python and PHP have sort of been... Oh, don't get me wrong. There have been releases in which they've improved performance. But what it lacked was a guarantee that every release, something about the core of the language, either memory efficiency or speed, would pretty much guarantee to be improved. Python 3 has spent an awful lot of years adding features, but not really focusing on reducing memory footprint, reducing the amount of processing power required, speeding up your code. PHP has made moves in speeding up code. I'm really impressed with PHP 7.4. Some of its benchmarks are truly extraordinary. But again, it's sort of like we decided this point release that we're going to improve the speed with the Google V8 engine. Every 6 weeks, something speeds up or becomes more memory efficient. Every 6 weeks. And that's just not something you get from PHP and Python. PHP and Python, every release, it's a roll of the die on what you get. But so I decided that to hitch my horse to Node.js pretty hard. And I actually think that Python has been, if not obsoleted, then at the very least being placed in a very much smaller niche of appropriate use cases. And, one of those niche use cases that Node doesn't do as well, and Python does very well, is machine learning. Pretty much mathematicians and statisticians have used Python exclusively for many, many, many years, and so they built up libraries that are incredibly fast, that just use Python as sort of a way to call into them. And that's great for them. But as an active consultant working mostly in database front ends and data analysis, Python has basically been relegated into such a niche that I just feel like anything Python can do, Node can do better. Or, in very few cases, everything Python can do, just wait 6 weeks for the next V8 release, and Node will do it better. I'm sort of drifting off into a lot of tangents, but I wanted you to know where I was coming from, what my philosophy is, and what my CV is, so you get sort of a context of what I'm trying to accomplish with this video series. One note at this point, in the middle of this episode, no episode will be longer than an hour. I'll get to an end of the thought, and if the episode is over an hour, then I get to the end of the thought and stop the video. I am going to try to do one video every day, and that video is going to be an hour long, and we'll see how that goes. But we still have 20 minutes left. So, why Rust? Rust is sort of my search for a language that works very, very fast for those times in which the equation of CPU time is more expensive than coder time. And I'm going to say at this point that that is vanishingly rare at this point for what I do. If you're in math or some sort of statistical analysis or whatnot, or if you're, I don't know, writing a huge 3D game or something that requires absolutely the most out of the hardware, then Node, Python, PHP are not the answers. When processing through massive amounts of data sets, you need a compiled language. You need to be able to churn through the data as fast as humanly possible, especially when you have a human being waiting on the other end for the results. And for my current client, for my consultancy work, they were dealing with tens of thousands of records. And I was supposed to create a report out of those tens of thousands of records. And coded something up in Node that did it. And we sort of have beta customers which provide us data to process. And it was taking between 4 or 5 minutes to generate this final report, this final data analysis report from 5 to 6 customers and tens of thousands of records. Well, once the site goes live, you could be talking about well, for our solution, dozens and dozens and dozens of sites, not millions and millions of users, but we're also talking about we could get up to, several 100,000 records that I have to churn through and analyze, and if it's taking 5 minutes now, so basically a minute per site, or a minute per customer, and it scales pretty linearly that way, as far as I can tell. That means if we, eventually get 50 customers, that's 50 minutes of processing. And let's just say that the person or people I'm developing this website for are not going to wait 50 minutes for a report. Or, yes, they will wait for the report for 50 minutes, but they won't be happy with me about it. And I can say that from the time I began developing this to now, running benchmarks, with no real code changes, I'm already 15 to 30% faster. That's just through Google's V8 engine improvements. And well, that's kind of impressive. I don't have to touch a thing, and I get 15 to 30% improvement. And yes, there's a wide spread in that percentage of improvement because there's different data being processed at different times. So it depends on the data that's flowing through the pipeline. But there comes a point at which, if we get 50 clients that use our data analysis, and it takes 50 minutes, I don't care if you have a 15% improvement. It's still too long. So, so I had to have something that would give me not just an order of magnitude faster improvement, but multiple more orders of magnitude faster. And while Node has saved me an enormous amount of coder time, the project I'm working on, if I tried to do it in a compiled language like, Rust, or C++ or anything like that, it would take multiple years. I was able to prototype the entire pipeline of my solution inside of 3 months. And, so saved my customer a huge amount of money. But the problem is that as impressive as the performance gains are every 6 weeks, it's still not enough to really account for the growth of our solution in terms of the number of clients that are going to use it. And so that's when, I like the phrase, premature optimization is the root of all evil. So my philosophy is always code the solution as fast as you can while still being effective, while still being bug-free. But once you finish coding it as quickly as you can, then you start doing some sort of performance analysis. And then you start doing benchmarking. Then you start narrowing down, where are the critical paths in your code where your performance is taking a dive? Is there any place in those critical paths that you can improve, which will remove the bottlenecks? And, in the solution that I was writing for my client, I noted several areas in which I could remove bottlenecks and really open up the taps and really have it running at full chat, instead of 1 minute per analysis of a site data. It would be 5 seconds or 10 seconds. And one of those is by threading where I can. JavaScript now has a threading model. And if I can, instead of going through a very tight one thread, one CPU, one thread pipeline, which is right now what my app does, instead multi-thread where I can. If you have 10 client sites that are pumping data to you and you have to process it through your analysis tool, there are significant portions of the pipeline in which those 10 clients' data doesn't interact with each other. Eventually it does. It eventually comes together in a nice, wonderful red bow that's tied. But for a majority of the pipeline, their data is separate, completely separate. And so right now, I take one site at a time, process it all the way through, then go to the next site's data, process it all the way through, and so on, one at a time. Well, when you're on an AWS instance with, an epic CPU with, 32 threads, and you're only using one of them, then you're wasting an awful lot of resources. They're just sitting there idle doing nothing that you're paying for, and you're not using 99% of it. So multi-thread where you can. And so that's one area in which I could improve my code many times fold, orders of magnitude fold. But there are also places in which I have to tie all these pieces of data together in a one beautiful bow. And there's no multi-threading it. There just isn't. It hits a funnel point, and little drips, end up going through it, and the pipeline grinds to an utter halt. And no matter how many improvements you make to the Chrome V8 engine, there is going to be a significant area in which you can optimize by moving to a compiled system language. And while I could easily do these things in C, C++, and by the way, I still might, I took it upon myself to, without charging the customer, kind of experiment around with, can I optimize using Rust? And especially, the data analysis tool. And so last week, I loaded up the Rust compiler in the tool chain and loaded the Rust plugins into WebStorm. And you can even see test Rust. See what I could do to take those places in which the pipeline narrows down to a very small nozzle and at least speed up the rate at which the data goes through that nozzle. And this is probably a really good place to stop this video because I gotten spoiled, really spoiled, by languages that not only could I grok inside of a couple of hours, but could basically become, quote unquote, an expert in an afternoon. With a minor hiccup with the whole async await thing in Node, which took me a while to wrap my head around. But even then, it was like, it was frustrating. But within a week, I was using promises like a virtuoso. I had no problem with them, and PHP was no problem. Python was no problem. I had gotten lazy. From 1995 on forward, my attitude of, for the problem domains that I'm interested in as a professional, Coder time is much more expensive than CPU time. Led me down a path to basically adopting three languages that look much like each other, act much like each other, and so I could easily just switch between the three without even thinking about it. And my skills at compiled languages basically withered away to nothing. And that's so when I first loaded up the Rust toolchain and started playing around it, obviously I read the Rust book, and it was somewhat helpful. Rust by example, look through that, and that was more helpful than the Rust book, but that's just because that's the way I learn. I learn by example. I don't learn by blue sky theory. And so, I did a couple of toy programs, just playing around with the borrower thing. And so I then said, okay, let's see if I can apply this to some real solutions to this project. And again, all this work, everything that I do here, these videos, the client's not paying for. I'm not invoicing them for these experiments into Rust at all. If my experiments into Rust bear fruit, then, and if it actively helps the project, then I might say, hey, I did some stuff on my own recognizance and on my own initiative without getting approval, and it seems to improve the project by a huge amount. Would you mind paying me for the hours that I used? But if they say no, I'm not going to get butthurt about it, because I'm basically doing this on my own just to learn Rust and to see if it has applicability to speeding up the data processing on the project. And I've run into difficulties. I've run into real difficulties. I'm not used to programming languages making me feel stupid. I'm somewhat arrogant about thinking that, hey, I'm really, 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 really smart, and I know whereof I speak. But in this case, I ran into a situation in which every moment that I experiment with Rust, I feel profoundly idiotic. And in the next videos, you're going to see exactly how idiotic I feel. So, thanks for listening. Thanks for watching. And the next video will actually start getting into coding in Rust. Talk to you later. Bye-bye.